Hey guys, what's happening? This is Dave for Beta Ready. Today, as fast as possible, what I'd like to talk to you about is the PID terms that we're going to be using in Betaflight. So basically, the PIDs are a set of 3 values that we use to make sure that the control system is able to actually react in a consistent and predictable way. The first thing to really talk about is the P term. Now, P stands for proportional. Basically, proportional you can think of in a really simple term as being the part of the control loop that actually reacts to your stick inputs. So it's reacting to what you're actually asking the quadcopter to do. So if I move the sticks or deflect them across, that sends a signal. The control system asks for a certain amount of deflection, so it tends to pitch the quad over or roll it and so on. And then what should happen there is, in a perfect world with nothing else happening, the quadcopter will stay in that orientation up until you ask for another change. Proportional just basically determines how quickly the quadcopter is actually going to react to that. A very high setting will tend to result in a very quick reaction, and sometimes too high we get overreactions. And a very low setting will result in a very sluggish reaction to it. So if you're flying with a very low P term, you'll tend to find it feels very wallowy when you actually do that. So with the P term reacting to our inputs when we're actually flying, you can think of the I term as being a part of the system that actually looks for and reacts to external inputs. So errors that are being introduced from something that's not our inputs. And that's going to be things like wind or center of gravity. So basically, say if your battery is sitting over your center of gravity and would normally be pushing the quadcopter forward, the I term is looking out for those sort of things, and it's, in a perfect world, it's correcting for them perfectly, and it's making it so that you don't actually notice that there's anything wrong with your center of gravity, or you don't notice the effect of the wind so much. And finally, the D term. D stands for derivative. The D term acts as a filter, so it effectively cleans up any unwanted movements as a result of the other 2 terms not being tuned properly. In a perfect world, we wouldn't actually need any derivative. We would get the P and the I set up perfectly, and we would keep it very low. So the main thing to realize is that you always want the D term as low as possible. Flying quadcopters, having the D very high can really put a lot of stress on the motor, and that's when you hear about people burning out their motors. But D is very good at removing oscillations from a slightly high proportional. It's very good to a point at removing things like the effect of prop wash. So when you're descending into your own dirty air, it can't correct it all usually, but it can do a job of really smoothing that out a lot. The other part comes down to how well you fly, so there's something to work on. The last real thing to talk about isn't actually the PID loop itself, but actually whether it's that important these days to actually spend a lot of time tuning it. I would argue you don't need to spend a lot of time. Systems like Betaflight work very well already. They've spent a lot of time fine-tuning the settings for the average user. And the reality is that we don't actually need to make a lot of changes, especially if you're new. That your time's going to be a lot better spent tuning in things like your roll rates. If you're interested, I've got a video somewhere which I'll link into, which talks a little bit about roll rates and stuff. Don't forget to like, subscribe, comment, thumbs up, thumbs down, hit the bell icon. You know, there's so much to do really. Aside from that, thank you for watching, and I'll see you hopefully on the next one.